The computer has been particularly glitchy today. Way more than normal.
Have you tried turning it off and on?
I did try turning it off and on when it informed me that it had achieved a critical error.
You tried turning it off and on?
I just let it finish.
Did you look at Task Manager?
No.
I gotta get the Jeopardy.
All right. There are 7 rules that apply to exponents, of which every single one of you already knows the first 6. Depending on who taught you 9th grade math, you might know the 7th, and you might not. It's no big deal, though. For some reason, though, even though there are only 7 things you can do for this entire section of this unit, and all those 7 rules are based on knowing how to fill in that chart, for some strange reason, exponents are done very poorly. And I do not know why. Hopefully, you people will be the class that breaks that horrible trend. Let's see. Now, as I referred to at the beginning of this little section on exponents, all of you already know how to do exponents with numbers. Depending on your grade 9 teacher, you may have used some variables, but you didn't have to. All you need to do is recognize that it is the exact same thing as using numbers. So let's start with this situation. The easiest one, and again, the first 6 of these you already know, so I'm going to go fairly quickly through them. The first one is multiplying powers of the same base. So that means I have a base, which is what? The big number or the little number? The big number. 3 squared times 3 cubed. Are those the same base?
Yes.
Indeed they are. And like I said, if you understand the simplest part of exponents, that what that little 2 and that little 3 means, then all the rest of this you don't even need to pay attention, because if you understand that, that's all you need to know. What does this 3 squared really mean? 3 times 3. So that means I got 3 times 3 times, what does 3 cubed really mean? 3 times 3 times 3. How many 3's do you have? 5. Math people are lazy. We don't like to write 3 times 3 times 3 times 3 times 3 times 3. So we write 3 to the 5th when we have computers that work. The rule, again, that you already know is if you have some base to some exponent and you multiply it by the same base to another exponent, the answer is that same base to the m plus n. That's the rule. Please notice that the x stays the same. It is not 3 squared, 3 cubed. It is not 3 times 3, which would be 9 to the 5th. The base doesn't change. Yeah? Yeah. Every one of you knows that already. Yeah? Yeah. Which means you all know the next one. 3 to the 5th divided by 3 to the 3rd. That is the same as 3 to the 5th over 3 to the 3rd. And once again, if you understand exponents, even if you had never seen exponents before, if you understand this in black here, you already know how to do this. That is 3, 3, 3, 3, 3, 5 3's over 3, 3, 3, 3 3's. 3 over 3 is 1. 3 over 3 is 1. 3 over 3 is 1. And what is left over? 3 squared. What's the shortcut? m minus n. And that only makes sense because division is the opposite of multiply, so the law is the opposite of the multiplying law. Again, you already know that. Even if I never showed you this shortcut, you know it simply because you're intelligent people. The third one, raising an exponent to an exponent. 3 squared cubed. Well, it's going to be the rest of a bracket when the computer starts working. What does that really mean? This is where it starts to get a little bit tricky. What is the base in number 3? 3 squared. What is the exponent in number 3? 3. So that means I have 3 squared how many times? Thrice. And you can quite plainly see that 2 is repeated 3 times. So it is really 3 to the 6th. Yeah? Yeah. And that is probably where x to the m all to the n equals x to the m times n. Now that is probably where every single one of you is perfectly comfortable to. Up to there. That was done to death in grade 9. All of you should feel good about it. Yeah? Yeah. The next 3, they're a little bit hazy, but again, you're intelligent folks. You know how to do it. A fraction base with an exponent. Somebody give me a fraction. Any fraction, but don't make either of the numbers 1.
3 over 4.
Great. 3 over 4. Now, the fourth exponent law says the base is a fraction. What must I do to that 3 over 4 to make sure that the entire thing is the base? I must bracket it. Lovely. Now give me an exponent.
7.
No, let me finish. An exponent greater than 1 but less than 3. 2. Lovely. Now, what does that mean? What's the base? 3/4. How many of them are there? 2 of them. Now you think back to grade 3 and Mrs. Bad Crumble and teaching you how to multiply fractions. And what do? 3 times 3, which is 3 squared over. 3 times 3 is 6, Louis?
No.
I didn't think so. 4 times 4 is 4 squared. And what do you notice? The exponent, the 2, went where? Look again. Both. Color?
Red.
Pink and yellow.
Left. Purple. No, we gotta do this.
Left.
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 Try mixing
The buzz!
two together.
That's a good choice because I was up late watching TV shows last night. 4 minutes. I was watching Kevin Probably Saves the World, which is a good show, and The Middle, which is a good show. If you don't watch either of those shows, I recommend them both. So, what did we notice about the exponent? That's one way to say it. I like to say it as the exponent goes to everything. So x over y to the m is xm over ym. And that's that law. Now, Exponent Law 5. A great many of you are aware of this one. 3, which is what I've been using all the way along. 3 to the 0 equals what?
1.
1. Your teachers taught you that and you committed it to memory. 3 to the 0 is 1, right? 10 to the 0. 1,796,394 to the 0. 1. Infinity to the 0. 1. Right? Okay. Just to make sure, this is why it works. What is 3 squared over 3 squared? That would be 9 over 9, which would equal 1, yes? But it's also 3 to the 2 minus 2, which equals 3 to the 0. So, if 3 squared over 3 squared equals 1, and 3 squared over 3 squared equals 0, then that must mean that 3 to the 0 equals 1, correct? That's just like first grade logic problems. If something equals something and something else equals that thing, then those two things equal each other. Right? That's easy peasy. But what screws all of you up are the permutations of that. For example, what is negative 3 to the 0? So some people are saying 1, some people are saying negative 1. And then what is negative 3 to the 0?
Okay, that's one, the top one's negative 1.
The top one is negative 1. And the bottom one is positive 1. Why?
Because in the top one, you're adding the negative after, and the bottom one, it's already in.
Yes. The negative is not part of the base in the top one.
And the bottom one
It is part of the base.
is known.
Okay. So the top one would be this. Negative 3 squared over 3 squared, which would be negative 9 over 9, which would be negative 1. Right? The bottom one is negative 3 squared over negative 3 squared, which would be negative 3, which would be negative 3 squared would be 9 over 9, which would be positive 1. Everybody good with exponent zeros? Sweet. And finally, number 6, the very last one that you already know. Because you already know number 4, you already know number 6. 3 times 5 squared is what really? 3 squared times 5 squared, or because they're numbers, you can do 15 squared, right? But that was a fast 4 minutes. Man, time flies when you're having fun and doing math, right? Yeah, it does. So what is that answer? Of course, it would be 9 times 45, which would be 225. No, you were right. 15 squared is 225. But, again, there's issues here. And that's why this one's number 6. Because at number 6, that's when it starts to get a little, you've got to start paying some attention. But first, the rule. Xy to the m equals x to the m, y to the m. Just like the fraction one. Right? And this is where grade 9 technically ended. Some of you may have gone into negative exponents. Did anyone?
I forgot.
Sweet. Okay. So, but before we go there, just like number 5 had some fuzzy bits around the edges, number 6 has some fuzzy bits around the edges. So what I'm going to do is I'm going to do a bunch of examples using the same number. All right? Because each example will build on the previous one. You guys need to be aware that it applies to everything. Okay? So I'm going to start with a real easy one. 3x 3x squared. What is that? Really? 3 squared, x squared. Would we ever leave 3 squared? Would we ever leave it written as 3 squared? No. Why? Because you can do it. It is what? 9. 9x squared. Yeah? Everybody's cool? Okay. Follow along. Remember, these 7 things are all equally applicable to all exponent questions. So if you're doing a question that looks like it only uses number 6, you don't get to forget about 1, 2, 3, 4, 5. Everybody cool? So let's try this one. 3x squared. Squared. What's that? 3 squared, and then x squared squared, which is 9x to the 4th. Everybody still cool? Yeah? Okay. 3x squared y squared squared. Three squared x squared squared and y squared squared, which would be 9 x4 y4. Lovely. And then 2 more of these fuzzy ones around the edges. 3x squared y squared x to the 3rd, all squared. Which would be 9. Yeah, 9x4, y4, x6. And then what would you do with the 2 x's? 9x10, y4. Yeah? Okay. And then one last one. 3x squared over 2x all squared. That puts in every law you've used or know so far except the 0 law. You already know what the top is going to be. We've already done that. What is it? Oh! 9x to the 4th is the numerator. 9x to the 4th. What's the denominator? 4x squared. Now what would you do with that? 9x what? Squared over what? 4. You haven't gotten rid of the 4. The 9 and the 4 can't do anything. Just the x's. Yeah? Okay. That is everything you knew from grade 9, but adding letters to it. Are we all okay? You're not great because you haven't practiced it in a long time, but you're all okay? Because this is a safe space? Excellent. Now we will go on to craziness. Mathematical insanity. That's why you have 3/4 of a page here, because negative exponents, they be crazy.
Are those variables excellent?
They are excellent variables. Why would you ever ask such a silly question? All right. What does this mean? 3 times 3. You take 3 and you multiply it by itself twice. What does this mean?
X times X.
X times X. Easy peasy lemon squeezy. What then does that mean? No, the base is X. The base is not negative X, the base is X.
X divided by X.
X divided by negative X would be negative 1. Okay, that's a good guess, because you don't know, right?
X divided by X.
X divided by X would be 1. Don't look at your calculator. Use your brain. Does this make any kind of logical sense? Because according to our exponent rules, the base must be multiplied by itself that many times, yes? How do you multiply something by itself negatively? You don't. So, what do you think? Yes. Why do you know that? Explain to me why that works. I understand it's called the reciprocal. So somebody taught you that shortcut, yes? Tell me why it works. You're not in trouble, because you're right. But do you know why it works? Okay. Let's explain it. Because she is absolutely right. You must use reciprocals. Here is how it works. 2 cubed is what? 2 times 2 times 2. And what is it for an answer? 8. 2 times 2 times 2 is 8. Yeah? Okay. What is the next logical descending exponent? Because right now we've got a positive exponent. We want to get to the negative. So what's the next one? 2 squared, which is what? 2 times 2, which is what? 4. What happened to this multiplication of 2? We got rid of it, right? Which means we divided by 2, didn't we? So here is divided by 2, correct? Okay. What is the next logical exponent? 2 to the 1, which is 1, 2, which is 2. What happened? We divided by 2. Okay. What is the next logical exponent? 2 to the 0, which is no 2's. 1, which evaluates as 1. What happened here? We divided by 2. If you do something thrice in math and it makes perfect sense, what can we assume? What is going to continue to happen? It's going to continue to happen. So what is the next logical exponent? 2 to the negative 1. We can't evaluate that because it makes no sense. But we do know that over here, we must divide by 2. 1 over 2. What's the next logical exponent? Negative 2, which must be 1 over 4. Notice, please, 2 squared, 1 over 4, 2 squared, 4. What is that 4 really? Because it's not really 4. What is it really? No. This 4 right here, what is it really? No. What is every single number in our universe really? Oh, good. Nobody knows this. They're really 4 divided by 1. We don't write the 1 because we don't write the 1 when we divide or multiply by 1. Please notice What happens here? 2 squared is 4 over 1. 2 to the negative 2 is 1 over 4. You just reciprocate it. That's what Kieran said. Now, she had what you do, but this is why it works. It's important to know why it works because of what I'm about to show you. X to the negative 2 is what? 1 over x to the, look at the exponents. This all makes sense. 1 over x to the 2. Makes perfect sense, right? Because that negative exponent isn't allowed. It makes no sense. Now, if you don't understand this stuff in blue, then what I'm about to write will be bothersome to you. I don't want to write it in blue because I've already done stuff in blue. Erase! Erase!
Get out of here.
Thank you. 1 over x to the negative 2. What's that? Because what part of that isn't allowed? The negative 2. So what do you got to do? You got to reciprocate again. So this is x squared. Good? Now put it all together. What is x to the negative 2 over y to the negative 2? Yes? 1 over x squared over 1 over y squared? Technically right. Barfy ugly. Tidy it up. Use what you know. Y squared over x squared. Is everybody good? That's everything you need to know about exponents, but it gets fuzzy down here. Here is how it gets fuzzy. Let's try a couple of easy ones. 3x to the negative 2. When it shows up, the 3x will be in brackets. What is that? Remember, every exponent law applies. 3 to the negative 2 and x to the negative 2. What there isn't allowed? Negative. So where do they go? To the denominator. So I end up with 1 over 3 squared and x squared. How do I finish that off? 9x squared. Good? Good? Okay. 3x squared to the negative 2. All exponent rules apply. 3 to the negative 2. X squared to the negative 2, which would be x to the negative 4. Now what? Three squared x to the 4th. 1 over 9 x to the 4th. Everybody still cool? Okay. 3x to the negative 2 to the negative 2. What there isn't allowed? Okay, is the x to the 4th allowed? So it doesn't go anywhere, but the 3 has to, and I get x to the 4th over 9. Is everyone still okay? Are you feeling this slightly slip through your fingers now, though? Are we getting to the point where you've really got to think? Okay. negative 3, x to the negative 2, y to the 2, all to the negative 3. Mr. Myers, that's a dick move.
Yes. Yes, it is. So now, how often would we see a question like this?
Lots.
Lots.
Lots. That's why this is the first day.
Can we go back to triangles? I miss the triangles.
Don't worry, we've got a quiz coming up on triangles.
Awesome.
Isn't it today?
Yes. That's why it's written on the board. Okay, what's happening here?
Haven't started yet.
This is where it starts. This is where you can go in one of two directions. You can follow the steps. Do this, do this, do this, do this, do this. Or you can apply some logic. If I follow the steps, where does that negative 3 go? Everywhere. So I'm going to have negative 3 to the negative 3. Agreed? And I'm going to have x to what power? Positive 6. And y to what power? Negative 6. Now, what there isn't allowed? Which negatives? I see a negative 3, a negative 3, and a negative 6. Only the exponents. That is okay. Negative bases are allowed. So, this whole guy has to go down to the bottom. And what changes? Not the base, just the exponent. Does that x to the 6th have to go anywhere? Why? Because it's a positive exponent. What about this y to the negative 6th? It has to go down there. And what happens to its exponent? 6. Can I evaluate that? What is it? Negative 3 times negative 3 times negative 3. Negative 3 times 3 times 3. Negative 27. X to the 6th over negative 27y to the 6th. That is pushing the extent of exponents for you people. If you can follow this, you're going to be A-OK. Everybody cool? I didn't say you have to be able to do it yet. Can you follow it? Then you're going to be okay. Now, what did I say? I said there's another way you could do this, yes? That requires you to use logic, not be like a robot. Do this, then do this, then do this. You can do something here that makes sense. And I'm going to show you over here. And you don't ever have to do this, but I'm going to show you. Observe. You just have to watch. You don't need to write this down, but please watch. I had negative 3x, negative 2, y 3, all to the negative 2, yes? No, it's to the negative 3. The y was squared. It was to the negative 3. Was that what it was? Yes. Okay. Now, what's the base? All of that, yes? Okay. Let's pretend that that whole base is one single thing, because that's what the brackets do, right? Everyone agrees. Yeah? Brackets group things as one single thing, correct? So is it all right if I wrote this as a to the negative 3? Does everybody see what I've done there? I have taken this big messy thing, and because it's in brackets, I've made it one single thing. Is that cool? Okay. Well, how would you simplify that? What did we do right here with a single thing? What did we do there? 1 over. So what can I do here? Isn't that 1 over a to the positive 3? And what was a again? Negative 3x to the negative 2y squared. All now to the positive 3. Then you can put all that in there and you'll end up with the same answer. Do I care which one you use? No. But I will tell you, this is very helpful when we go one step further, which would be this. I'm going to erase the red here. Is that okay? It's been recorded. You can take this one step further. Now what's the base? This whole thing. And what does a negative exponent do to a fraction? What did it do to a fraction? It flipped it over and it changed every negative exponent, right? Here's where it gets tricky. If I flip this over, you can see there's 1, 2, 3, 4, 5 exponents. Which is the only one that will change if I flip this? The negative 3 out here. Everything else stays the same. Because this is the same as a to the negative 3. Are you all with me? This is the hardest thing you can do, which is why I'm showing you this little trick. Because if you do this one, hoppity, 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 and do every single step, it's going to take 30 years, isn't it? But if you change it once at the beginning, that saves you like 12 steps. Everybody cool? Do you need to do it? No. Is it a good idea? Yes. Are we going to do lots of practice with this? Yes. Are we going to start very, very easily with it? Yes. Everybody cool? All right. So, you people are now at the point where page 81 to 82, you're going to do all of it. And 83 and 84, you only have to do the circled ones. Now listen to me. You have a quiz on trig right now, and you are in class for 45 more minutes. The other class needed 25 minutes for everybody to be done this quiz. So here's what I'm going to do. I'm going to hand it out. You're going to start on it. When you finish, you're going to start working on 81 to 84. All right? For which? For 81 to 84? As much as you feel you need to. I can't stress this enough. If you try to do this stuff in your head, I can do that in my head. Can you? Trying to do it in your head to avoid writing down a couple of pieces of work. Is it worth it? Show work when you need to. Do you need to show me work for b squared times b cubed? No, that's b to the 5th. Do you need to show me work for a to the 16th, b to the 24th, c to the 3rd, divided by a to the 8th, b to the 12th, c to the 1? Yeah. Everybody understand? Okay. Now, you're going to write that quiz. You're going to work on 81 to 84. When is 81 to 84 due? No, because what's happening tomorrow? Your trig test. Thursday. So, if you don't finish 81 to 84 in class today, should you work on it tonight? No, because what should you be preparing for tonight? Your test on what? Go for Myers. Indeed I do. I would assume so because she is still on a crutch. I will check. Hey, Aisha, you still have the elevator key? Yes. Should I tell her what you just told me? Okay. No problem. Bye. Turn the elevator every day. And then you got to get it again in the morning because the custodians need it. All right. Where was I? Oh, yeah. You're preparing for trig, right? The quiz I'm about to give you is all real-life trig. So you will notice when we do it, there are parts of trig that I did not put on it. Because trig is trig. If you can do sine, you can do cos and tan. If you can do cos, you can do san and tine. Strike that. Reverse it. If you can do cos, you can do tan and sine. And if you can do tan, you can do sine and cos. Got it.
San and tine? What the heck is that?
Okay. Everybody cool?
We're talking about sin or something?
While the quiz is getting handed out, do two things. One, get your calculator out. Make sure it's in degree mode. Two, if you need your data booklet because you cannot remember SOHCAHTOA, have it out. Then you better remember SOHCAHTOA. Because I told you approximately 1,000,000 times, so you never come to class without your data booklet if you can't remember the things that are in it. I guess you're going to have trouble then, aren't you? I'll say it again. SOHCAHTOA. Don't know what to tell you. Remind me what would happen to you if you were a mechanic and showed up to a job without tools. You would not get that job. Remind me what would happen if you showed up at McDonald's without your uniform. They would send you home to get it. So remind me what will happen in math class if you show up unprepared. You will receive what you deserve, which is a mark showing that you are unprepared. Right? They won't let me teach you guys stuff that I feel you need to know, so I'll teach you lessons that you need to know. If you ask me really nicely, maybe I'll write SOHCAHTOA on the board and what it means. Everybody else, you're going to be going on this quiz right now. It is 8 multiple choice questions, 4 one-triangle questions, 2 two-triangle questions, but the 2 triangle questions, the triangles are drawn for you. Okay? Take one, pass it around. If you finish your quiz, you work on your purple book.
Outrageous orchid.
Outrageous orchid. I will be at the front playing backgammon. That's kind of a brotherly move. Well, you know the word I was going to use. That's how brothers treat each other. That's the wrong quiz. Yes. Well, take one more minute because I don't have it on this page anyway. we have 8 minutes left in class, and that's how long it will take. I know that it's not down. All right. Let's go, let's go. Okay, man joke. They don't count for marks. Don't worry about it. It's something you need to study, right? A, C, D, and C. Any questions? Turn the page over. B. I cannot remember. I think it is C.
Yes.
Yes! For 1 mark. 6.8, I believe.
I got 6.9 with rounding.
Okay. I'm going by memory. 2 things here. 1 for the drawing. You had to put the 80 on the short side. Right? I don't care how you do it. You could have drawn it lying down, but the 80 had to be there. This was 30.6. That's got you 1 mark, and then your answer of 173 point blah got you the 2nd mark. Because, of course, you did tan. Opposite over adjacent, 30.6, tan 80. The slide makes the angle of 38 with the ground. Slide takes up 3.1 of ground space. That's the drawing you needed for 1. Solving the question, I believe it was 2.7. 2.4, great. Which was 3.1 times tan 38. A was 5, so x equaled the square root of 5 squared plus 5 squared, which is the square root of 50, which is 7.1. Once you had 7.1, b was 4. So y equaled the square root of 4 squared, which is 16, plus 7.1 squared, which is 50, square root of 66, which is 8.1-ish, for 2 marks. Pardon? That's fine. That's fine. You're good. And this one, T was 52, A was 30, B was 45, so X equaled 45 divided by tan 52, which was 35 point blah, which meant the whole thing was 65 point blah, so it was 65 point blah times tan 52, and I can't remember what it was, 83 point blah for 2 marks, giving you a score out of 18. Great. Test tomorrow. If you are going to the mountain, have a good day. Remember, it is your responsibility to get that test written ASAP.
Can I have your eraser?
Oh, it was your eraser?
Yeah.
I threw it back at Seamus. Seamus! It's Louis' eraser.
Are we handing this in?
No, you report it to me tomorrow on your test.
I got one.
Where did it go? On the floor near your chair, he said.